What would you think if I told you that the ground beneath your feet is not merely a solid foundation of rock and soil, but a vast, breathing conductor of electrical energy, pulsing with a rhythm that has existed since the dawn of time? It is a concept that defies the simple intuition of the everyday world, yet it sits at the very heart of the universe's energetic architecture. Most of us walk upon the earth unaware that we are traversing the surface of a colossal dynamo, a spherical capacitor charged with immense potential. But in 1899, one man did not just walk upon this surface, he listened to it. He tuned his instruments to the heartbeat of the planet and discovered a secret that could have revolutionized civilization, the phenomenon of stationary waves. Nikola Tesla, in the isolation of his Colorado Springs laboratory, peered into the electrical soul of the world and found that the earth itself could be made to resonate, to sing in unison with a man-made electrical impulse, carrying power to the furthest corners of the globe without the need for wires. To understand the magnitude of this discovery, you must first strip away the modern understanding of radio and telecommunications, which relies heavily on the work of Heinrich Hertz. The Hertzian wave is a radiation, a beam of light that travels in a straight line, dissipating its energy into the void of space as it moves further from its source. It is light, it is heat, it is the broadcast signal that fades with distance, but Tesla saw something different. He envisioned a system not of radiation, but of conduction. He perceived the Earth not as a barrier to be overcome, but as the perfect medium, a spherical conductor of infinite capacity. If you strike a bell, the sound does not radiate into space and vanish. The metal of the bell vibrates, the energy trapped within its structure, resonating until the entire form hums with acoustic power. Tesla believed the Earth was that bell. The setting for this revelation was the high-altitude plateau of Colorado Springs. Here, the air was thin, the lightning storms were violent and frequent, and the electrical noise of industrial civilization was virtually non-existent. It was the perfect crucible for an experiment of planetary proportions. In a wooden laboratory that looked more like a barn than a scientific institute, Tesla constructed a magnifying transmitter of unprecedented size. This was not merely a machine, it was a harmonic instrument designed to grip the electrical earth. His goal was not simply to send a signal from point A to point B, but to pump electrical fluid into the ground and observe how the planet reacted. He operated on the principle of resonance, the same principle that allows a singer to shatter a crystal glass with the right pitch. If he could find the resonant frequency of the earth, he could feed energy into it, and that energy would not diminish, it would accumulate, building upon itself until a standing wave was formed. Imagine dropping a stone into a calm pond. Ripples expand outward in perfect circles. When those ripples hit the bank of the pond, they do not disappear. They reflect back toward the center. If you time your drops perfectly, if you drop the stone at the exact moment the reflected wave returns, the energy combines. The peaks get higher, the troughs get deeper. The water is no longer just moving, it is oscillating in place. This is a stationary wave. Tesla realized that electricity behaves exactly like that water. If he injected a current into the earth at a specific frequency, the wave would travel to the opposite side of the planet, the antipode, and bounce back. If he continued to pump current in rhythm with this returning wave, the electrical potential would rise to astronomical levels at specific points on the globe, creating nodes and antinodes of immense power. On the night of July 3, 1899, nature provided the proof that Tesla had been seeking. A massive storm broke out over the mountains, a violent display of atmospheric electricity. But this was no ordinary observation. As the storm moved away from his laboratory, traveling east over the plains, Tesla monitored his sensitive receivers connected to the earth. He watched the needles dance. Common logic dictated that as the lightning moved further away, the signal received at the lab should grow weaker and weaker until it vanished. This is the law of distance. Energy fades as the square of the distance increases. But that is not what happened. As the storm drifted, the signals fluctuated rhythmically. They grew strong, then weak, then strong again, even as the storm moved miles away. Tesla sat in stunned silence, his mind racing to interpret the data. The signals were not fading into the abyss, they were passing through electrical peaks and valleys fixed in the geography of the crust. The lightning strikes were triggering the Earth's natural electrical resonance, creating stationary waves that spanned the distance between the storm and his lab. The Earth was responding to the lightning like a taut string responds to a pluck. It was vibrating. This moment was the pivotal verification of his theory. The Earth was filled with electricity, and that electricity moved in predictable, resonant patterns. It meant that the planet was finite and conductive, capable of sustaining a standing electrical wave. You must grasp the implications of this. If stationary waves could be artificially induced, then energy would not need to be pushed through the resistance of a wire, losing power with every mile. Instead, energy could be retrieved anywhere on Earth with 97% efficiency. A receiver in London or Tokyo or the middle of the Pacific Ocean, simply by tuning to the frequency of the standing wave, could tap into the planetary circuit. The energy would be everywhere, available to everyone, as free and abundant as the air we breathe. This was not just science, it was a restructuring of the fundamental economics of human existence. Tesla's experiments in Colorado Springs pushed the boundaries of high-voltage physics. He generated artificial lightning measuring 135 feet long, creating thunder that was heard 15 miles away. He electrified the ground around his lab so intensely that sparks flew from the feet of walking horses and butterflies were seen with halos of St. Elmo's fire around their wings. But these were not mere spectacles, they were the side effects of tuning the primary coil to the resonant frequency of the Earth. He calculated this frequency with astounding accuracy, estimating the wavelength of the stationary wave based on the circumference of the Earth. While modern science identifies the Schumann resonance, the electromagnetic resonance of the atmosphere, at 7.83 Hertz, Tesla was working with the conduction resonance of the physical globe itself, operating at frequencies he believed would allow for the industrial transmission of power, not just radio signals. The skepticism he faced was immediate and lasting. The scientific community was wedded to the Hertzian model. They could not conceive of a wireless system that did not use radiation. To them, a wave that did not radiate was a contradiction. But Tesla insisted that radiation was a waste, a loss of power. In his system, the energy remained in the system, the Earth ionosphere cavity, conserved and magnified. He often spoke of the ether, a concept now discarded by physics, but his functional understanding of wave mechanics in a medium was flawless. He viewed the wireless transmitter not as a lamp radiating light, but as a pump creating pressure. The stationary wave was the manifestation of that pressure stabilizing across the globe. In the solitude of the Colorado Plateau, Tesla became the first human to effectively hold the Earth in the palm of his electrical hand. He wrote of the experience with a reverence that blurred the line between physics and spirituality, though he remained strictly a man of logic. The Earth is responsive to faint impressions, he noted. It is a medium of transcendent sensitivity. This sensitivity meant that the input of energy required to sustain these waves was theoretically minimal once the wave was established. Like pushing a swing, you only need a small nudge at the right moment to keep it going high. Tesla believed he could keep the entire electrical potential of the planet swinging high enough to power all of humanity's needs forever. To fully grasp the mechanics of what Nikola Tesla was attempting in Colorado Springs, you must suspend the conventional image of a radio tower broadcasting a signal into the air. That is the Hertzian model, a model of radiation where energy is lost to the void. Tesla's model was hydraulic. He visualized electricity as a fluid, an incompressible fluid that permeated all matter. In his mind, the Earth was a rigid metal ball filled with this fluid. Now, imagine a pump attached to this ball. If the pump forces fluid in and out at a slow, rhythmic pace, the fluid within the ball expands and contracts. The pressure changes are felt instantly and uniformly throughout the entire volume of the sphere. This was Tesla's vision of the world system. The magnifying transmitter was the pump, and the electrical fluid of the Earth was the medium. He was not trying to send a message across the ocean. He was trying to change the electrical pressure of the entire planet, making the Earth itself the carrier of the signal. When a stationary wave is established on a sphere, a fascinating geometric phenomenon occurs, one that Tesla mapped with mathematical precision. The point where the transmitter is located acts as the north pole of the wave. As the electrical impulse is driven into the ground, a ring of potential expands outward like the ripple on the pond, but curved to fit the globe. This ring grows larger and larger until it reaches the equator of the wave, not necessarily the geographic equator, but the point equidistant from the transmitter and its antipode. At this equator, the wave is at its widest, spread across the massive circumference of the Earth. Here, the amplitude is lowest because the energy is spread thin. But as the wave passes this midline, it begins to converge. The ring tightens. The energy, previously spread out, is forced back together, focusing, concentrating, until it reaches the exact opposite side of the Earth, the antipode. At this antipode, something miraculous happens in the physics of resonance. The wave does not dissipate, it reconstructs itself. The convergence of the wave creates a surge of pressure, a node of immense potential, almost identical in strength to the source at the transmitter. You could theoretically place a receiver at the south pole of the wave, on the other side of the world, and receive the energy with nearly zero loss because the Earth has focused it for you. Tesla calculated that the energy would travel to the antipode and bounce back to the transmitter in a specific time interval. By timing his next pulse of electricity to coincide exactly with the return of the first wave, he achieved constructive interference. The second wave rides on the back of the first, the third on the second, building a tower of energy that grows until the losses from resistance exactly equal the input power. This is the definition of resonance, the accumulation of energy in a vibrating system. In the wooden sanctuary of his Colorado lab, Tesla built the machine necessary to achieve this, the magnifying transmitter. This was not the standard Tesla coil found in modern science museums, which is a toy compared to the beast he unleashed in 1899. A standard Tesla coil consists of a primary and a secondary circuit loosely coupled. But Tesla realized that to ring the Earth, he needed to liberate the voltage from the magnetic weight of the transformer. He added a third coil, the extra coil. This was a freestanding helix, connected to the secondary but magnetically isolated from it. Its sole purpose was to allow the electrical surge to swing freely, gaining momentum, magnifying the voltage to tens of millions of volts before it was discharged into the Earth. The extra coil acted like a springboard, launching the electricity with such force that it could overcome the natural resistance of the planetary crust. You might wonder, how does this affect the air? If the ground is the conductor, what is the atmosphere? In Tesla's design, the atmosphere was the insulator, the dielectric of the spherical capacitor. However, he knew that air, when subjected to high enough voltage, breaks down and becomes conductive. He observed that at higher altitudes, the air is thinner and more conductive, the rarefied strata he often referred to. He proposed that if he could push the voltage high enough, he could create a conductive path not just through the ground, but through the upper atmosphere, sandwiching the planet in a global circuit. But the primary mechanism remained the ground current. The stationary wave was a telluric phenomenon. He measured the resistance of the Earth and found it to be incredibly low for these specific frequencies, contradicting the scientists of his day who believed the Earth was a vast resistor that would swallow any current fed into it. Tesla's understanding of frequency was the key to unlocking this terrestrial door. He was not working with the gigahertz frequencies of modern Wi-Fi or the megahertz of FM radio. Those waves are tiny. They scatter and reflect. Tesla was working with the base notes of the universe, very low frequency and extremely low frequency waves. He operated in the range of 6 to 20 kilohertz, and sometimes even lower, down into the single digits of hertz. He calculated the resonant frequency of the Earth based on the speed of light and the planet's circumference, arriving at figures that are startlingly close to the Schumann resonances discovered physically in the 1950s. Tesla effectively discovered the Earth's resonant cavity half a century before mainstream physics had the tools to detect it. He realized that the Earth rings like a bell at roughly 8 cycles per second. To power the world, one simply had to strike the bell at this rate. The implications of this technology went far beyond simple power transmission. They touched upon the manipulation of time and space in the transmission of information. Tesla made a controversial claim that still baffles researchers. He stated that the wave traveling through the Earth did so at a velocity exceeding the speed of light. Before you dismiss this as impossible under Einstein's relativity, consider the mechanics of a phase wave. If you have a rigid rod extending from New York to London and you push one end, the other end moves almost instantly. The mechanical impulse travels at the speed of sound in the material, but the phase of the movement can appear simultaneous. Tesla argued that because the Earth is an incompressible charge carrier, the pressure of the electricity would be felt at the antipode with a delay that suggested a velocity of pi over 2 times the speed of light. He did not see this as a violation of physics, but as a unique property of stationary waves in a conductive sphere. In the laboratory, the effects of these standing waves were visceral. When the transmitter was active, the laboratory became a part of the circuit. The air filled with ozone, the distinct sharp smell of electrified oxygen. Sparks would jump from water faucets in nearby mining cabins. Light bulbs planted in the ground miles away, with no wires connecting them to the lab, would flicker and glow, powered solely by the ground currents rushing back and forth beneath the soil. This was the world wireless system in its embryonic stage. It was a demonstration that energy need not be confined to a copper cable. The Earth itself was the wire, and it was a wire that could handle infinite load. However, the generation of stationary waves required absolute precision. If the frequency drifted by even a fraction of a percent, the resonance would collapse. The wave returning from the antipode would be out of sync with the new wave being sent, causing destructive interference. The waves would cancel each other out, and the energy would vanish into heat. Tesla spent sleepless nights tuning his capacitors, adjusting the inductance of his coils, listening to the rhythmic clicking of the spark gap. He was acting as the conductor of a planetary orchestra, ensuring that every electron moved in perfect harmony. The spark gap, a rotating switch that discharged the capacitors, had to fire thousands of times per second with mechanical exactitude. It was the heartbeat of the machine. This technology also introduced a profound shift in how we view the consumption of energy. In our current grid, if you turn on a light, the power plant must burn more coal to meet that demand. The energy is sent to you. In Tesla's stationary wave system, the energy is already there. The wave is oscillating globally. Your receiver, the light bulb in your home, does not pull energy from the transmitter directly. It taps into the ambient potential of the Earth at that location. The transmitter keeps the wave swinging, replacing only the energy that is drained by the receivers. It is a system of maintaining potential rather than pushing current. It is the difference between drinking from a river that is always flowing versus asking someone to carry a bucket of water to your house. The river is the stationary wave. As the experiments in Colorado concluded in early 1900, Tesla packed up his notes, convinced he had handed humanity the keys to the future. He had proven, at least to his own satisfaction, that the Earth was a conductor, that it had a resonant frequency, and that stationary waves could be established to transport power. He left the high plains with a vision of a tower that would rise in Long Island, Wardenclyffe, a tower that would act as the first commercial node in a global network. He believed he had solved the riddle of the energetic universe, but he was about to face a world that did not understand his language of vibrations, a world dominated by the tangible, profitable copper wires of the telegraph monopolies. He had found the cosmic pulse, but the world was not yet ready to listen to the beat. To translate the ethereal success of Colorado Springs into a reality that could power civilization, Tesla had to leave the isolation of the mountains and return to the center of capital and industry, New York. He carried with him not just data, but a blueprint for a machine that would act as the heartbeat of the world. This brings us to the tragedy and the grandeur of Wardenclyffe. Located on Long Island, this was never intended to be merely a radio station, as history books often mistakenly categorize it. It was a terrestrial power plant. To understand the function of Wardenclyffe is to understand the supreme architecture of stationary waves on an industrial scale. The tower, rising 187 feet into the air with a 68-foot copper mushroom cap, was the physical manifestation of the equations he had balanced in the Rockies. But the most critical part of Wardenclyffe was not what towered above the trees. It was what lay buried beneath them, a secret that defined the difference between a radio antenna and a planetary resonator. Most radio towers are grounded simply to provide a reference point or safety. For Tesla, the ground connection was the primary active component. Beneath the tower, he excavated a central shaft 120 feet deep, lined with timber and driven with iron pipes. From the bottom of this shaft, he pushed radial iron pipes horizontally into the water table, creating a massive subterranean root system. Why go to such lengths? Because to create a stationary wave, you must grip the earth. You cannot simply touch the surface. You must couple your machine to the conductive strata of the planet with absolute electrical solidity. He was building a hydraulic pump for electricity, and a pump is useless if it does not have a secure intake into the reservoir. The reservoir was the Earth's charge. The tower was designed to oscillate the electrical potential of that entire subterranean region, shaking the electron sea of the planet until the wave propagated to the antipode and back. This is where the divergence between Tesla and the rest of the scientific world became a chasm. While Tesla was building his earthshaker, a young Italian named Guglielmo Marconi was racing to send a signal across the Atlantic using Hertzian waves. When Marconi succeeded in 1901, sending the letter S from Cornwall to Newfoundland, the world cheered. They believed Marconi had done what Tesla promised, but cheaper and faster. They were wrong. You must understand the fundamental difference in the physics. Marconi was using high-frequency radiation, waves that travel through the air, bouncing off the ionosphere, though he didn't know it at the time, and skimming the surface. It was a fragile signal, barely detectable, drowning in static. It was communication, yes, but it was not power. It was a ripple on the surface of the water, whereas Tesla was moving the entire ocean. Tesla looked at Marconi's success with a mix of frustration and pity. He famously remarked, "Marconi is a good fellow. Let him continue. He is using 17 of my patents." But the tragedy was that the financiers, including J.P. Morgan, did not possess the scientific literacy to distinguish between a Hertzian wave and a Tesla stationary wave. To a banker, wireless was wireless. If Marconi could send a message with a simple wire suspended from a kite, why did Tesla need a massive tower and a deep shaft? They did not understand that Tesla was not trying to send a Morse code beep. He was trying to energize the globe. He was trying to create a system where you could stick a rod in the ground in the middle of the Sahara Desert and run a heavy motor, light a city, or navigate a ship without a compass. He was building a utility, not a telegraph. The mechanics of the stationary wave at Wardenclyffe relied on the principle of the quarter wave. Tesla designed the height of the tower and the length of the secondary coil to be exactly 1/4 of the wavelength of the electrical vibration he intended to generate. In wave mechanics, the quarter wave resonance is the most efficient way to maximize voltage at the top of the tower while maximizing current at the bottom. Think of a whip. The handle, the bottom, moves very little but with great force, current, while the tip, the top, snaps wildly with great speed, voltage. The copper mushroom at the top of Wardenclyffe was the tip of the whip, accumulating a massive electrostatic charge ready to break down the air and create a conductive path to the ionosphere, while the roots deep underground pumped the high current amperage into the earth. It was a perfect harmony of sky and soil, utilizing the entire planetary cavity as a resonant chamber. However, the laws of economics are often more brutal than the laws of physics. As the stationary wave theory required a massive initial investment to prime the pump of the planet, the return on investment was not immediate. Moreover, there was a fatal flaw in the business model of the world system. You cannot put a meter on a stationary wave. Once the Earth is resonating, anyone, anywhere, with a simple tuned coil, could tap into the power for free. There is no way to restrict access to the ground beneath a customer's feet. J.P. Morgan, the titan of monopoly, realized this. If energy became ubiquitous and free, where was the profit? The concept of free energy here does not mean creating energy from nothing that violates thermodynamics, but rather the cost-free distribution of energy. The fuel, coal or hydro, would still be burned at the main plant, but the distribution grid, the miles of copper wire, the telephone poles, the transformers, would be rendered obsolete. The Earth would be the grid. In 1906, the funding dried up. The workers left. The machinery was sold for scrap. The tower, the greatest instrument ever conceived for the study of terrestrial harmonics, stood silent, a monument to a future that was aborted. In 1917, fearing it might be used by German spies, the U.S. government blew it up. Dynamite shattered the wooden struts, and the great tower fell. But the physics did not die with the tower. The concept of the stationary wave remains a valid solution to Maxwell's equations. In fact, modern science has quietly vindicated Tesla in fragments. We now use ELF, extremely low frequency, waves to communicate with submarines deep underwater, because these waves, Tesla's waves, penetrate the conductive salt water where high-frequency radio fails. We know the Earth rings. We know the ionosphere is a conductive shield. The components are all there, admitted by science, but they are kept in separate boxes, never assembled into the singular global machine that Tesla envisioned. What would have happened if the switch had been thrown? If the Wardenclyffe oscillator had achieved resonance? Tesla predicted that the stationary waves would not only carry power, but would allow for the modification of the environment. He theorized that by manipulating the electrical potential of the atmosphere, we could control the weather. Rain could be drawn to drought-stricken areas. Shipping lanes could be illuminated by the induced glow of the excited ocean. The very night sky could be made to shine with the brilliance of a permanent aurora. By standing in the center of the stationary wave, humanity would have moved from being a species that adapts to the environment to a species that tunes the environment. We must also consider the terrestrial clock aspect of his discovery. A stationary wave beats with a precise rhythm. Tesla envisioned a world where every clock, every machine, was synchronized to the master oscillator at the transmission tower. Universal time, accurate to the microsecond, available everywhere. No more local discrepancies, no more mechanical drift. The pulse of the civilization would be locked to the pulse of the current flowing through the ground. It was a vision of total integration, energy, information, time, and location, all carried on the back of the standing wave. The suppression of this technology is often framed as a conspiracy, but it is perhaps more accurately described as a collision of paradigms. The world chose the path of separation. Distinct fuel sources, distinct wires, distinct nations, distinct markets. Tesla offered a path of unity. One Earth, one circuit. The stationary wave is a phenomenon of the whole. You cannot have a standing wave on half a planet. It requires the entire sphere to participate. Perhaps that was the true danger. It forced a realization of global interconnectedness that the geopolitical mind of the 20th century was not ready to accept. As we stand today, surrounded by a web of inefficient wires and radiating antennas that waste 90% of their energy heating the space around them, we are living in the shadow of the Hertzian limitation. We have optimized a flawed system. We have become masters of radiation, ignoring conduction. We shout into the void, hoping someone hears, while Tesla offered a way to whisper into the ground and be heard by everyone. The ground beneath us is still waiting. The resonant frequencies are still there, humming silently, waiting for the impulse that will once again drive them into a standing wave. The physics hasn't changed, only our willingness to look down instead of up. It is often said that history is written by the victors, but in science, history is written by the Standard Model. The Standard Model of electromagnetism, codified by Heaviside and Hertz, declared that the primary mechanism for wireless transmission is radiation. We accepted this. We built our entire telecommunications infrastructure upon the backbone of the transverse electromagnetic wave, the Hertzian dipole. Consequently, we have forgotten the longitudinal possibilities, the scalar potentials that Tesla dedicated his life to mastering. Today, when we hear wireless charging, we think of placing a phone on a magnetic pad, a short-range inductive coupling that drops off within millimeters. Or we think of beaming microwaves from satellites, a dangerous and inefficient method of radiative transfer. These are trivialities compared to the world system. We have become experts at throwing pebbles, while Tesla was trying to move the tides. One of the most persistent misunderstandings in modern alternative science is the conflation of the Schumann resonance with Tesla's terrestrial stationary waves. You will often hear that Tesla discovered the 7.83 Hz heartbeat of the Earth. This is technically imprecise, and the distinction matters. The Schumann resonance, predicted in 1952, stands as a standing wave in the atmosphere, trapped between the conductive surface of the Earth and the conductive ionosphere. It is an electromagnetic wave in the air. Tesla, however, was adamant that his wave was a current flowing through the crust, a mechanical electrical vibration of the solid globe itself. While the frequencies are harmonically related, the medium is different. Tesla was driving the ground, Schumann observes the sky. By failing to distinguish between the two, we fail to appreciate the radical nature of Tesla's proposal, that the ground you stand on is not a sink for electricity, but a pipeline. Modern physics has begun to quietly revisit the mechanisms Tesla described, primarily through the study of xenic surface waves. Unlike a standard radio wave that radiates outward in a sphere, a xenic wave is glued to the interface between two media, in this case, the Earth and the air. It propagates along the surface with very low attenuation, rolling over the curvature of the Earth like a tsunami across the ocean. This fits Tesla's description of his non-radiating wave far better than any Hertzian model. If Tesla successfully generated high-power xenic waves, he solved a propagation problem that modern 5G engineers are still struggling with. He found a way to utilize the Earth-air interface as a waveguide, allowing energy to slide around the planet rather than piercing through it or bouncing off the sky. But we must also face the darker, more analytical questions regarding this technology. If we were to reactivate a Wardenclyffe-style transmitter today, what would be the consequences? We are not living in the empty radio silence of 1900. Our world is saturated with electromagnetic smog. We are bathed in the noise of billions of devices. Introducing a planetary-scale stationary wave of high voltage could have unforeseen interactions with our delicate digital electronics. Would the induction from the ground current fry the microchips in our servers? Would the electrostatic potential rising from the soil disrupt the navigation of aircraft? Tesla's world was analog and robust. Ours is digital and fragile. The very technology we have built in his absence might be the biggest obstacle to his return. Furthermore, there is the question of the Earth's geological stability. Tesla often spoke of the mechanical analog to his electrical experiments. He claimed that with a small mechanical oscillator attached to a steel frame, he could build up resonance until the structure shattered, the famous earthquake machine myth. If the Earth is indeed a piezoelectric crystal, a structure that converts mechanical stress into electricity and vice versa, then pumping terawatts of electrical power into the crust at a resonant frequency could theoretically induce mechanical tectonic effects. Could a standing electrical wave trigger earthquakes? Could it manipulate the magma flows deep beneath the mantle? We treat the Earth as an inert rock, but Tesla treated it as a living, reactive dynamo. Tinkering with the resonant frequencies of a planet is not merely an engineering challenge, it is an existential risk. Yet, the allure of the stationary wave remains undeniable in the face of our energy crisis. We are currently tearing the planet apart to extract fossil fuels, burning them to boil water, to spin turbines, to push electrons down copper wires that lose significant energy to resistance. It is a brute force approach. We are fighting the medium. Tesla's approach was Aikido. He used the medium's own weight and resistance to throw the energy where he wanted it. A global stationary wave system would allow us to generate power at the most efficient locations: solar in the Sahara, geothermal in Iceland, hydro in the Amazon, and retrieve it anywhere else with minimal loss. It would decouple energy generation from energy consumption. The geopolitical stranglehold of oil pipelines would vanish, replaced by the democratization of the terrestrial circuit. We must also consider the monopole nature of Tesla's system. Current electrical theory is based on the dipole, positive and negative, out and back, the closed loop. Tesla's tower was a monopole, the Earth was the other pole. He was operating an open system that interacted with the ambient charge of the cosmos. This touches on the most controversial aspect of his work, the idea that the system could eventually become over unity by tapping into cosmic rays or the ambient energy of the ether. While standard physics rejects this as a violation of thermodynamics, Tesla believed the stationary wave was the key to opening a valve to an inexhaustible reservoir of cosmic energy. He wasn't creating energy, he was using the standing wave to harvest it from the environment, much like a windmill harvests wind. The silence of Wardenclyffe is not just the silence of a ruin. It is the silence of a path not taken. We chose the path of privatization and metering. A stationary wave cannot be metered easily. It is a common good like the air. Perhaps that is why it remains suppressed. The physics challenges are immense, yes, impedance matching the crust, preventing the breakdown of the atmosphere, safety from high-voltage step potentials. But the economic challenge was always the insurmountable wall. We have built a civilization on the scarcity of energy. Tesla offered a physics of abundance. The two concepts cannot coexist. As we look at the stars and dream of wireless futures, we must look down. The secret is not in the signal bars on your phone, it is in the dirt. The mechanism for planetary unity has been sitting in the patent office for over a century, gathering dust, labeled as an eccentric impossibility. But the equations of the stationary wave do not care about patents or profits. They only care about resonance. The Earth is waiting for the conductor to step back onto the podium, to lift the baton, and to strike the note that will make the world hum once again. But until we are willing to abandon the safety of the wire and embrace the terrifying freedom of the standing wave, we will remain tethered to our limitations, burning matter to fight the dark. Are we prepared to accept the catastrophic collapse of our current economic and technological paradigms in exchange for the ultimate liberation of energy? Or is the chaotic unpredictability of a resonant global circuit a price too high to pay for a free lunch?